Hi folks, this is Karim Raouf from IT Visualizer channel. We will continue our lab, the Matrix Labs, the video number 88. We have been discussing in the previous video the following. We are still working with troubleshooting using Event Viewer. We have seen in the previous video that I have already from a couple of years a PDF that contains some specific event IDs that any IT administrator should focus on. It is related to security. Some of them are related, for example, to login and log off events. Some of them are related to PowerShell scripting if there is someone running a script, maybe a hacker or something. A lot of things actually, and we have seen when we feed the AI tools with this PDF and ask them to create hands-on exercises and some security cases, we see that Claude, I think its answer is very detailed, very creative than ChatGPT. Anyway, we will see a lot of changes in the AI community in the couple of days coming with God will, because we have seen that, for example, ChatGPT o3 is on the way, and they say that it will exceed all of the currently AI platforms or AI tools. So I will continue using Claude 3.5 Sonnet and ChatGPT o1 to create more scenarios from the PDF that I have talked about from a couple of seconds. Today, we will talk about security case, okay, concerning these events that are contained in the PDF, and an explanation, on the other hand, from Claude 3.5 Sonnet, an explanation between the junior IT and the senior IT concerning the content of the PDF and the important event IDs included in it. We will see how these two scenarios, a security case and a dialogue or explanation dialogue, we will see how these two will give us more information concerning the events we should focus on. So let's first begin with ChatGPT o1, and let's see the security case or incident response table top exercise. Here is a case. Let's see if I can read it first. I can read it from here, or it will fail like every time I do that. Let's see first how we can, if we can read it from the read loud section. So for example, here it is. If we try to read this loudly.
Incident Response Tabletop Exercise. Welcome to the exercise. We'll focus on building your ability to identify, analyze, and respond to security incidents in an Active Directory AD environment. Phase 1, Identification. Scenario Overview. You, the Junior IT Administrator, receive an alert from your SIEM, Security Information and Event Management System. The alert indicates unusual activity involving a privileged account. A quick
Again, it failed. I don't know why. So we will try to use the built-in read out loudly. Let's try to read it so we can go wrap and next steps, and here we go, and here it goes. We cannot read here from out loudly or read out loudly. Why? Something very strange. We cannot read this here. Okay, anyway, so let me read it for you guys. If we go further and see the explanation concerning this exercise. So first of all, this is the identification phase. You are the junior IT administrator, receive an alert from SIEM, Security Information and Event Management System. This alert indicates unusual involving activity, involving a privileged account, maybe a domain admin or enterprise admin account. Here we can see the log entries, multiple failed login attempts from domain admin account. This is a domain admin account from an unfamiliar IP address. Maybe this is an outside IP address. This is not from your internal network range. Okay, so here you can see this is the type of, or the event ID 4625, failed login attempts from the event viewer on the domain controller. login type 3 network login. So this refers to an access on a shared folder on maybe on the file server or something. So this is a failed login and he's trying to access a shared folder. Okay, alert 2, the domain admin successfully logs in from the same IP address, and this is the network login. So I think here he is working, or he's trying to access a shared folder, okay, or a printer or a shared printer, but logically it will be a shared folder. So then we can see this failed login, then we have the successful login, and then we have change or alert 3. We have two alerts. The alert number 3, changes detected in group policy object. So what he have does, this hacker, system audit policy change. So he's closing or disabling the audit policy or the audit option for certain events in our domain or in our network, just I think to not to record his trace or to record his actions. Okay, we can see also event 4732, this user is added to the domain admins group. So he is not an admin yet, okay, but he's trying to add him to the domain. So this is a normal account, he failed to log in, he's trying to access a shared folder in the network, and then he has, after successful hacking process, he added this account to the domain admins group. Okay, alert 4, a scheduled task was created on the domain controller. So now he has created this task on the domain controller just to, if we disable this account, he will have some trails or some backdoor that will install maybe a malicious script or something. It is on ctemp malicious so and so. So this is the event. We see all of these events we have discussed in the previous video or different exercises. So this is how the AI can use it in a security case. Okay, so we will continue with the case. Your task, Junior IT, analyze the provided logs and alerts, identify any indicators of compromise or IOC, okay, indicator of compromise, IOC, formulate an initial hypothesis about the nature and the scope of the incident. Okay, let's see your response, which is all automatically generated by the AI. Okay, I asked him, or I told him to generate my response as a junior admin and his response as a senior admin. Okay, analyze of logs and alerts. Alert 1, multiple failed logins from AD admin account originating from this IP address. The failed login attempts suggest brute force or password guessing. Login type 3 indicates a network-based attempt, not an interactive local login. Network-based attempt, okay? It's on the network, okay? So it's not local, not physically on the machine. This is a network-based. But I think we can see from another PDF we have used in the previous video, if we can see event 3, this is network mapped drive. So he is trying to access a mapped drive. Okay, so this is as you can see here, login type 3. Okay, so anyway, if we continue with our scenario, let's go and see indicate 3 based. Okay, a successful login from admin from the same IP address shortly after failed attempt. This may mean that attacker eventually guessed the password and stolen the credentials. That's correct. Alert 3, group policy objects were changes. The AD admin account added a user to the domain admins group. This indicates privilege escalation. The attacker may be solidifying their access by granting admin permissions. Okay. Then alert 4, we have a scheduled task that is already running was created. This looks like the attacker is trying to maintain persistence by running a malicious script on the domain controller. So this is the analyzation of the junior IT. We can see indicators of compromise, unfamiliar IP address. I think this is not from their internal network IP range. Multiple failed logins followed by successful login. Group membership change. Okay, this is correct. Suspicious schedule task creation. So this is like a summarization of what is happening. Initial hypothesis, domain admin account has been compromised, likely through a password guess attack or stalling. I think this is not a domain admin account. because he's added him to the domain admins group. This is a normal account, okay, and he guessed his password and then he added him to the domain admins group because this is not what he said before. The attacker escalated privilege of modifying group policy and adding users to domain admin group. So he added the same user or he added a different user. If we go and see, added a user to the domain admin, so he has compromised the account. And what does he do exactly? Let me see. So user is added, so the same user, so this is not correct. This is maybe a fault from the AI because this is the same account. You need to be a different one. Anyway, so we will continue. Maybe, okay, he added another one, okay? Just if this is disabled, he have another account to play with. Okay, the attacker establishing persistence through a malicious schedule task. Here is the feedback from the senior IT admin. Great job identifying the key events and connecting the dots between the failed logins, GPO changes, and the schedule task. Let's refine your analysis. Failed logins, you correctly identified brute force as a possibility, but also consider password spraying, where an attacker tries one password across many accounts. So this is another kind of attacking. Brute force, I think he is focusing upon one account and try to guess his password, or password spraying, where an attacker try one password across multiple accounts. Okay, brute force for one account, password spraying for with one password on different accounts. Privilege escalation. Event ID 4732 is critical. Privilege group modification are a huge red flag in AD. Schedule task is an indicator of persistence. Schedule tasks often enable attackers to execute scripts remotely. Okay, the hypothesis is solid. The AD admin account was likely compromised and the attacker is escalating privileges and maintaining access. Okay, actual findings. The attacker used a stolen password to log in as a admin. Persistent attacker created a schedule task in this location. Privilege escalation, attacker added additional accounts to the domain admin group. Okay, tools and techniques. Analyze logs from event ID, event logs for event 4625, 4624, 4719, 4698. Here is the PowerShell. This is the analyzation just to go and view these events, and then there is a PowerShell query. Users added to privilege groups. This is the PowerShell commandlet get AD group member identity domain admins recursive. So to see if there is any newly added users. SIM to correlate alerts across logs. Okay, this is the case. Now we have the contamination or contaminate and eradication and recovery. So let's see how we can solve this issue step by step. We need to contain the incident, remove the attacker access, and recover the environment. Your task as a junior IT admin. Here are your options. Choose the best course of action and justify your decision. Contamination, we have three options. Disable the account immediately. Revoke network access for this IP using a firewall, so we will block any current connection to this external IP address using a firewall rule. Stop the malicious schedule task. So I think this is the logical steps, or this is correct. Okay, this is the first. We have to contaminate. These are the steps. Eradication, remove the malicious user from the domain admins group, delete the schedule task, search and remove any suspicious script on or malware on the domain controller. Okay, this is correct. Recovery, reset the password and enable multi-factor authentication. Perform a group refresh to reverse unauthorized changes to get it from a backup if he has changed the audit policy. Okay, monitor AD for further unusual activities. I think this is all of them are correct, and in the specific order. Yes, this is correct. Okay, your response. So all of these, this is still with the junior. So this is, I think this is these are the steps, your task. Here are your options. To the best course of action. So he's giving you options and you choose from them. Okay, so you choose in which order you will begin the contamination. This is first, or this is first, or this is last. So he's giving you all of the things, and then you need to reorder them as you see equivalent or as you see necessary. So first thing, I will disable the admin account to cut the attacker access. I will block. These are two very, very important steps to do. So he didn't, for example, stop the malicious schedule task. So he used the first two first. Okay, and second, I will remove the schedule task and delete the malicious script. So, okay, this is first, this is second, this is third. I will check for any malicious files or schedule tasks across all of the domain controllers. Then recovery, I will reset the password and enforce MFA for all privileged accounts, not this account in specific. I revert and refresh group policies to ensure unauthorized changes are removed. I will enable increased auditing in AD to monitor future suspicious activities. Okay, feedback from the senior. Can you hold for 1 minute, guys? Let me see something. So let's continue, guys. Let's see the feedback of the senior IT admin. Good decisions. Here is the breakdown. Contaminate. Disabling the account was correct, but blocking IP address might not stop the attacker if they pivot to another system. So how this? Maybe this is the centralized firewall. He is talking about. I think he's referring to the local firewall software or the Windows firewall. Okay. He will block it from the workstation or from the or from the domain controller Windows firewall. I think this should be done from the main firewall or the hardware firewall. If he's talking about the local software or local firewall software, this is can be a good point. You should not. This may not block him because maybe he is already hacked another domain controller. Eradication. Deleting the malicious task and script is critical, but ensure you check other systems for similar IOCs. So he's referring to checking if there is any other scheduled task on other domain controllers. Resetting password and enforcing MFA are excellent steps. Refreshing group policies ensures no remnants of the attacker change. So this is good. Here we can disable the account by this PowerShell commandlet. Search for scheduled tasks. This I think he will search for that on each domain controller. So you need to work with this command on each domain controller. Okay. Audit group membership to see if any other users are added to the domain admins group. Wrap up and key takeaways. By the end of the study, you have learned how to identify suspicious activity using events like 4625, 4719, and 4698, how to contain and response to compromised accounts and privilege escalation, the important tools like PowerShell, SIM, and Event Viewer in Active Directory incident response. Next step, implement regular audit reviews for privileged accounts. These are future steps. Enforce multi-factor authentication MFA for all privileged users. Create an incident response playbook for Active Directory security incidents. Okay, so this is a small exercise or a small security incident. So I asked him to give me 3 more incident response tabletop exercises for the rest of the event IDs. Okay, so there's a lot of events we can use. Okay, for example, detecting unauthorized group membership changes. Okay. Okay, so this is, I think, very, very simple. This is a user that is a normal user that is an HR user added to the domain admins group. And we will see this is the log entry, okay, or this is event 4732 domain admins. This is the user performed by unknown admin. This is the time and this is the source IP address from which this operation was done. Your response, your event, you will see that the event, the domain admins, the user, unknown, the performing account, unknown admin. This is the source IP address. Indicate a rogue account. This IP needs further investigation to know its location and ownership. Maybe it's not also from the internal network IP range. Unknown admin account. Okay, disable the account, remove the user, reset the password, increase audit logging for group membership changes. Well done. We identify the group. Let's back identify the group change and trace it back to unknown admin. We need to know view the source IP using tools like Whois or its internal asset management to check it's from within the organization. So Whois will give us, but I think Whois is for the external IPs. So maybe this is an external IP, but if it is internal IP, we need to know who is holding this IP address, maybe from the DHCP server, if we have something like that. This is also to check group membership, so we know that's unknown admin. Maybe he is in this domain admin's group. Check the IP address, so it's correct. Then relate to unknown admin. So okay, anyway, so this is also some techniques to continue with the scenario. So we have analyzed the event, query group membership, correlate group changes with other events. Okay, this is exercise 1. Exercise 2, schedule task. I think we have done this before. So this, he is also, he is trying to give them in separate cases, but I think we have done this before. So this is also the task. This is event 4698. This is the script, the executable created by so and so. So again, we go and see the thing, and then he used PowerShell to get the content. So this is like displaying the content of the script added in the schedule task. Look for special commands like invoke web requests. So maybe he is in the script, he is getting, or this script will go and download some files from an external site or website. Okay, contaminate and eradication, disable or delete the schedule task. This is how you can unregister the account. Okay, delete the script. So this is good because this was not stated in the first exercise, okay, or the original exercise. This is will register, unregister the schedule task, remove the script as a whole. Then we will check for any unusual schedule task on all of the other where object is task path like temp. So here is just checking if this there is maybe other schedule tasks, okay, like temp. This is the one. I think he will search the schedule task by the name of task path. Okay, so he's searching for any schedule tasks that have a path to this folder ctemp. Okay, this will be done on all of the domain controllers or locally on the server. So this is good. He will check for task path. Okay, this is good. If we go further, number 3, we have seen unauthorized login attempts. We have seen this before. Okay, we can continue feedback. So he didn't do. Where are the rest of the events? So I think I'm telling him because he have repeated all of the events again with. So the first exercise was good, but he is repeating the same events in separate exercises. So here I'm asking him to give me all of the IDs or event IDs in the PDF. So I have already uploaded the PDF to him and he is giving me exercises on them. So let's see. Group policy changes. We have seen this before also. This we have seen group policy changes uh, in the first exercise. So quickly, so here again, for example, if we need to see uh, someone, just a moment, guys. So let's continue, guys. Here we have like this PowerShell commandlet to get if there is any group policy changes. We are now exporting all of the group policies configuration, and then we can this is, I think this is the get report. Okay, so we are getting all of the configuration of all of the group policies in XML file, and we will revise this current configuration with a backed up group policy configuration. Okay, you can actually do a simple commandlet through GPO-ZOR PowerShell commandlets to see when these group policies was changed. So this is why GPO-ZOR PowerShell commandlets are very, very useful. Okay, so if we continue with the scenario or other scenarios, we can see here this is ChatGPT giving us a lot of scenarios concerning different event IDs listed in the PDF. So for example, access to sensitive files, we have event 4663. Okay, we have seen how we can make uh, object access to have or to audit an access on a file share or on a shared network drive or shared network folder. We need to activate the audit or object access audit option and then go to the folder and activate the auditing option on the folder. Okay, so this is the event. If we go further, we can see, for example, if we have already activated the audit object access and we have already a folder that we have activated the auditing option on it, we will see event 4663 in the event viewer. We can see this is the file, this is the user, we have the read and write access, this is the time of the access. Okay, so we have another thing, for example, IT support to delete. So here is the junior IT. For example, for this scenario, he's seeing this IT support unauthorized file access. So IT support doesn't have access to this folder. So this is one thing. So maybe he's added himself to the permissions on the folder so he can delete the file or something. Delete access. So deleted the file without approval. Okay, so anyway, we can see that uh, here we can see this enable object. This is how we can do this. We can enable audit on the folder. Okay. Anyway, so we can continue. Now he is seeing the share permissions on the folder that contains the Excel sheet. So this is a case where a finance Excel sheet is accessed by the IT and he has deleted it and he should not have access to it. So and this was recorded under event 4663, and to do that we should have the audit object access first enabled on the file server or uh, on the server that we need to audit files on, and then we specify a certain folder to audit to be audited, like right click the folder, then properties, then advanced security, then advanced, and then we can validate or enable the audit. So here the senior IT is trying to get the permissions on the folder that contains the Excel sheet to see if the IT have any access or any privileges on it. Okay, so this is good. And then we have event 4103 and 4104. This is to see if there is someone has run a malicious script, maybe under PowerShell. So we can see something like this. For example, 4103 invoke credential harvest. This is like a PowerShell commandlet. It was run by backup admin. Command export credentials, so on. So this is very, very clear that it is a hacking process. Someone is trying to get the credentials of or cached credentials on a workstation or on a server. Okay, this is event 413, and then we have 414. This is like a sample output of these events. So again, we need to activate PowerShell auditing feature on the server, and then so we can be able to have these events recorded in the event viewer. Okay, so we can see, for example, that the PowerShell commandlets is run and then exported in a certain location. This is all listed in the commandlet itself. If you go there, we can see here this is the commandlet event 4104. So this is it. We need to investigate these credentials and indicate if there is anything already recorded, and then we need to stop. If if this script is currently running, we need to stop the PowerShell session or the PowerShell that through it we run the malicious script to get the credentials if it's still running. Or we need to see on other servers maybe this process is running or these commandlets are running. We need to see that, and then we need to remove the item, the credentials that is already recorded by this PowerShell commandlet, and we need to see the backup admin, the user that already run this PowerShell commands. We need to reset it. Maybe it is hacked, and this is a privilege account, okay, that can or have privileges on the server. We need to reset the password, and okay, that should do it. Okay, as we can see here, this is a lot of scenarios, even though they are not that complex. But let me show you all what Claude has done. Actually, every time he gives me a very detailed real life scenario. It is very complex answer. It is developing every line and line. You will see that every time the scenario is getting bigger, and if you see it is very logic, and it is very real to world life scenarios. Let's see the answer of Claude, or when I ask him to explain the event IDs that I have given him in the PDF. Okay, a lot of events we need to focus on. Let's make or let him explain this through a dialogue between the junior IT and the senior IT. But again, let me go and do something here. I need to see something here. Monitor script review. Okay, so I think this is, I need to do something here. Okay, so let me, okay, let's first read the answer. So here we go. We will answer, or we will read a very large answer. So if we go there, and let's see how this will go, because it's a very large answer. And okay, still we are going the answer again. Okay, is there anything else? Okay, so here it is. Let's read out loudly. Okay, but let's first go.
Notice how we're building in both security controls and operational flexibility. Should we continue with notification? Let me simulate this teaching interaction, focusing on Windows event logging in Active Directory. Senior IT. Let's start with understanding event log monitoring in Active Directory.
Sorry guys, let's wait for a moment. So let's continue, guys.
Directory. Can you explain what Windows event logs are and their importance in AD management? Junior IT. Well, event logs are like records of things that happen on Windows servers. In Active Directory, I think they show when users log in and stuff. We can see them in that event viewer thing. I know they're important for troubleshooting, but I'm not really sure about all the different types. Senior IT. Good start. Let me help expand on that. Think of event logs as your organization's security camera system, but for digital activities. Let's break this down with a real-world scenario. Imagine you're managing a bank. You need to know who accessed the Vault authentication events, when they accessed a timestamp, what they did inside activity logging, if anyone tried to break in, failed attempts. In Active Directory, event logs work similarly. Can you think of how these banking examples map to AD activities? Junior IT. Oh, I think I get it now. So, Vault access equals user logons. Event ID 4624. Break-in attempts equals failed logons, 4625. Activities inside equals what users do after logging in, but I'm not sure where to find all these different logs or how to set them up properly. Senior IT. Excellent parallel. Let's create a simple exercise. I want you to open Event Viewer on a domain controller. Navigate to Security Logs. Filter for event ID 4624 successful logons. What do you see? Try to identify who logged in, from where, what type of logon it was. Junior IT. Okay, I see lots of entries. There's something called Logon Type 3 and some show Logon Type 2. There are different account names and some show computer names. Should I be concerned about all these entries? Senior IT. Good observation about the logon types. Let me explain. Type 2 equals interactive. Someone physically logged onto the machine. Type 3 equals network. Accessing shared folders/printers. Type 10 equals remote desktop. Best practice tip. Focus on setting up monitoring for after-hours logons, suspicious timing. Multiple failed attempts, potential brute force. Admin account usage, privileged access. Would you like to try creating a basic monitoring policy for these scenarios? Junior IT. Yes, that would help, but I'm worried about getting too many alerts. How do we know what's normal versus suspicious? Senior IT. Perfect concern. This is where baseline documentation comes in. Let's create your first monitoring setup. Enable auditing. PowerShell. Copy. Auditpoll/set/category. Logon/logoff/success. Enable/failure. Enable. Document normal patterns. Regular business hours logons. Expected service account activities. Normal admin maintenance windows. Would you like to work through setting up alerts for after-hours admin logons as a practical exercise? This interaction demonstrates building from basic concepts to practical application. Using relatable analogies, Bank Vault. Encouraging hands-on learning. Addressing real concerns, alert fatigue. Progressive skill development. Should we continue with setting up those alerts? Or would you like to explore a different aspect of event log monitoring? Copy. Retry. Oh, yes. Senior IT. Excellent. Let's set up alerting for after-hours admin logons. First, I want you to think about what constitutes after hours in your organization and what admin activities might be legitimate during these times. Junior IT. Well, our business hours are 9 a.m. to 6 p.m., Monday through Friday. Sometimes IT does maintenance on weekends, but it's usually scheduled. Should we consider anything outside these hours as suspicious? Senior IT. Good thinking. Yes, let's use that as our baseline. I'll guide you through creating a basic PowerShell script to monitor and alert on after-hours admin activities. We'll build this step by step. First, let's create the script structure. PowerShell. Copy. Hashtag event log monitor for after-hours admin access. Hashtag purpose. Monitor and alert on administrative logons outside business hours. $business hours start equals 9 a.m. $business hours and equals 18 6 p.m. admin group if equals S 1-5-21-***512. Hashtag domain admins group SID pattern hashtag function to check if current time is during business hours function is business hours $current hour equals get date. Hour $current day equals get date day of week if $current day and Saturday, Sunday. Return $false return $current hour G $business hours start. And $current hour LT $business hours end. What do you think this initial code does? Junior IT. It looks like it's setting up when business hours are and checking if we're in them, but I'm not sure about that SID part. What's that doing? Senior IT. Good catch. The SID is a security identifier. It's a unique way to identify the domain admins group. Let's add the monitoring part. PowerShell. Copy. Hashtag main monitoring function monitor admin logons $filter equals at log name equals security. ID equals 4624 hashtag successful logon start time equals get date. .add minutes -5 hashtag check last 5 minutes. Hashtag get relevant events $events equals get twin event filter hashable $filter error action silently continue for each $event and $events. Hashtag convert event to XML for easier property access $event XML equals XML $event dot to XML. Hashtag check if logon is administrative AF $event XML event.event data. Data value like asterisk dollar. Admin group as a D asterisk. If not is business hours. Hashtag alert on after hours admin logon send alert email event $event. Now let's test this. What potential issues should we watch out for? Junior IT. Well, we might get too many alerts if multiple admins log in. And what if it's scheduled maintenance? Will this alert anyway? Also, where are these alerts going? Senior IT. Excellent concerns. Let's enhance the script with your suggestions. PowerShell. Copy. Hashtag add approved maintenance Windows $maintenance Windows equals at start equals 2024-01-20T22:00:00 end equals 2024-01-21T05:00:00. Hashtag example maintenance window. Hashtag add approved admin list for maintenance $approved admins equals at maintenance.admin backup.service. Function is approved maintenance perum $timestamp $username. Hashtag check if within maintenance window $is maintenance time equals $false for each $window and $maintenance windows. If $timestamp G $window dot start and $timestamp $la $window end $is maintenance time equals $. True break. Hashtag check if approved admin $is approved admin equals $username and $approved administrator is maintenance time and $is approved admin. Let's test this. Can you create a test logon event during after hours and see if it triggers? Junior IT. Sure, but how do I safely test this without causing actual security concerns? Senior IT. Great security mindset. Here's how we can safely test. Create a test user with no actual admin rights. Use PowerShell to simulate an event without actually creating one. Run the script against our test data. PowerShell. Copy. Hashtag test event simulation $test event equals at time created equals get date that add hours 12. Hashtag set to midnight username equals test.admin logon type equals 2 hashtag test our functions $result equals is business hours right host is business hours $result equals is approved maintenance timestamp $test event time created username $test event that username right host is approved maintenance $result. Want to try running these tests? Would you like to proceed with testing? Or should we review any concepts we've covered so far? Copy. Retry. Oh. Proceed with the testing. Senior IT. All right, let's run through a complete test of our monitoring setup. I'll guide you through each step and explain what we're looking for. First, let's create our test scenario. PowerShell. Copy. Hashtag create a temporary test directory new item path C /event log test. Item type directory hashtag create our test script $test script equals at hashtag test event log monitor hashtag. This is a safe testing environment $current time equals get date right host current time. $current time hashtag simulate after hours admin login $test event equals at time created equals get date add hours 12. Username equals test.admin. Logon type equals to computer name equals $NV. Computer name, right host, simulated event details. Right host time, $. Test event time created. Right host user, $test event username. Right host logon type. $test event logon type. Hashtag test our business hours function is business hours equals is business hours right host in business hours check. Right host is during business hours. Is business hours. Hashtag test maintenance window check is maintenance equals is approved maintenance. Timestamp $test event time created. Username $test event username right host and maintenance window check. Right host is approved maintenance. Is maintenance. At $test script out file C /event log test /test monitor.ps1. Try running this script. What output do you see? Junior IT. I ran it and got some output about the current time and that it's not business hours. But how do I know if it's working correctly? Should we test with different scenarios? Senior IT. Excellent question. Yes. Let's test multiple scenarios. Here's an enhanced test suite. PowerShell. Copy. Hashtag test scenario generator function test monitoring scenarios $scenarios equals at description equals normal business hours login time equals get date. Date.add hours 10. Hashtag 10 a.m. username equals regular.admin expected equals no alert. Normal hours. At description equals after hours unauthorized login time equals get date. Date.add hours 23. Hashtag 11 p.m. username equals suspicious.admin expected equals alert unauthorized after hours. At description equals scheduled maintenance window time equals get date. Date.add hours 22. Hashtag 10 p.m. username equals maintenance.admin expected equals no alert approved maintenance. For each $scenario and $scenarios. Right host n equals testing. $scenario. Description equals. Test admin logon time $scenario. Time. Username $scenario. Username right host expected result. $scenario. Expected. Start sleep seconds 2 hashtag pause between tests. Hashtag function to test individual scenarios. Function test admin logon $time $username. Right host time. $time right host username. $username is business hours equals is business hours $is maintenance equals is approved maintenance. Timestamp $time username right host business hours. $is business hours right host approved maintenance. $is maintenance. Run this enhanced test suite. What results do you see? Are there any scenarios we should add? Junior IT. I see the different test cases running. The after hours one triggered an alert which seems right. But in a real environment, how will we handle false positives? And should we be logging these somewhere? Senior IT. Great operational thinking. Let's add logging and fine-tune our alerting. PowerShell. Copy. Hashtag add logging functionality function right monitor log perm. String $message. String $level equals information. $log path equals C. /event log test /admin monitor .log $timestamp equals get date format. YYMDDHH. Assess $timestamp. $level $message add content path $log path. Hashtag enhance alert function with threshold checking function send alert email perm $event. Hashtag check alert threshold recent alerts equals get content C. /event log test /admin monitor .log select string pattern /alert where object $_match get date to string YYYMDD. If $recent alerts count G5 right monitor log alert threshold exceeded. Sending summary instead of individual alert. Level warning. Hashtag here you would implement summary alert logic return hashtag log the alert right monitor log after hours admin login detected. $event. Username. Level alert. Hashtag here you would implement your actual email sending logic. Let's run a full test including the logging. What elements of the monitoring would you want to adjust for your environment? Notice how each addition builds on your questions and concerns, implementing real-world considerations while maintaining a learning progression. Would you like to explore any specific aspect of the monitoring system in more detail? Copy. Retry. Oh. Continue. Senior IT. Excellent. Let's build upon our testing and implement some real-world monitoring scenarios. I'll walk you through setting up practical alerts and monitoring that you'd use in an actual enterprise environment. First, let's enhance our monitoring to include context awareness and pattern detection. PowerShell. Copy. Hashtag enhanced monitoring system hashtag purpose. Provide comprehensive AD security monitoring with context awareness hashtag author. Your name, hashtag last updated. Current date, function get logon pattern perm, string $username. In $hours previous equals 24. Hashtag create a more sophisticated pattern analysis $previous logons equals get twin event filter hashtable at log name equals security. ID equals 4624 start time equals get date .add hours $hours previous. Error action silently continue where object $_ properties 5 value. EQ $username write monitor log, analyzing logon patterns for user, dollar username, level information, hashtag return pattern analysis at total logons equals dollar previous logons. Count unusual times equals dollar previous logons where object dollar login hour equals dollar underscore dot time created. Hour dollar login hour LT dollar business hours start or dollar login hour G dollar business hours end. Count source computers equals dollar previous logons. Properties 11. Value, select object unique. What do you think this pattern analysis might help us identify? Junior IT. I think it would show if someone's logging in at weird times, and maybe if they're logging in from different computers than usual. But how do we know what's actually suspicious versus just someone working late? Senior IT. Great observation. Let's add context-based alerting that considers normal patterns. PowerShell. Copy. Hashtag context-aware alerting function evaluate alert context perum $event $pattern $alert level equals low. Hashtag default alert level $alert reasons equals at. Hashtag check for high-risk conditions if $pattern unusual times GT3 $alert level equals medium $alert reasons plus equals multiple after hours logons detected. If $pattern source computers count GT2 $alert level equals high $alert reasons plus equals multiple source computers in short time frame. Hashtag check for concurrent logins concurrent sessions equals get active sessions username event properties 5 value if concurrent sessions count GT1 $alert level equals high $alert reasons plus equals concurrent sessions detected write monitor log alert evaluation completed level $alert level information return at level equals $alert level reasons equals $alert reasons pattern equals $pattern. Let's test this with some real scenarios. Here's a test case. What would you expect to happen? Junior IT. I see it's checking for things like multiple logins and different computers, but what's a normal number of source computers? And should we be looking at failed login attempts too? Senior IT. Excellent questions. Let's add failed login monitoring and baseline deviation detection. PowerShell. Copy. Hashtag baseline deviation detection function compare to baseline perum $username $current pattern. Hashtag read baseline from configuration $baseline path equals C / event log test / baselines / $username the JSON if test path $baseline path. $baseline equals get content $baseline path convert from JSON hashtag calculate deviation percentage $deviation equals at logon frequency equals math : abs $current pattern total logons $baseline average logons / $baseline average logons time deviation equals math : abs $current pattern unusual times $. Baseline average unusual times / $baseline average unusual times location deviation equals math : abs $current pattern source computers count $baseline average source computers / $baseline average source computers return $deviation else write monitor log no baseline found for user $username creating new baseline level. Warning, hashtag initialize new baseline $baseline equals add average logons equals $current pattern total logons average unusual times equals $current pattern unusual times. Average source computers equals $current pattern source computers. Count $baseline convert to JSON out file $baseline path return $null. Would you like to create some test baselines and see how the system detects unusual behavior? Junior IT. Yes, that would help. But how do we know our baselines are accurate? And what happens if someone's behavior legitimately changes, like if they start working different hours? Senior IT. These are exactly the kind of operational considerations we need to address. Let's implement adaptive baseline updating. PowerShell. Copy. Hashtag adaptive baseline management function updates user baseline perum $username $new pattern. In $adaptation period equals 30 hashtag days to consider for adaptation. $baseline path equals C / event log test / baselines / $username .json. $baseline equals get content $baseline path convert from JSON hashtag calculate weighted average Recent patterns have more influence. Dollar weight equals 0.3 hashtag 30% weight to new patterns dollar baseline that average logons equals dollar baseline dot average logons asterisk $1 weight plus dollar new pattern dot total logons asterisk dollar weight. Dollar baseline dot average unusual times equals dollar baseline dot average unusual times asterisk $1 weight plus dollar new pattern dot unusual times asterisk dollar weight. Dollar baseline dot average source computers equals dollar baseline dot average source computers asterisk $1 weight plus dollar new pattern dot source computers count asterisk dollar weight. Hashtag add timestamp for baseline age tracking dollar baseline dot last updated equals get date format YYYMDDHH. Assess dollar baseline conversation out file dollar baseline pathright monitor log. Updated baseline for user dollar username. Level information. Let's run through a complete test scenario with initial baseline creation, normal activity monitoring, detecting unusual patterns, baseline adaptation. Which part would you like to test first? This interaction demonstrates progressive learning, addressing real operational concerns, and building practical solutions. Would you like to proceed with testing any specific component? Copy. Retry. Oh. 1. Senior IT. Perfect. Let's start with initial baseline creation. This is a crucial first step in establishing normal behavior patterns. I'll walk you through this process step by step, explaining each component. PowerShell. Copy. Hashtag initial baseline creation script hashtag purpose. Establish normal behavior patterns for AD user activities. Hashtag we'll create this in stages to understand each component. Hashtag first. Let's create our baseline structure function. Initialize security baseline parameter mandatory equals $true. String $username int $data collection days equals 14. Hashtag we'll look at 2 weeks of historical data. Right host starting baseline creation for user. $username right host analyzing $data collection days of historical data. Hashtag create our baseline storage location. If it doesn't exist, $baseline folder equals C /event log test /baselines. If not, test path $baseline folder. New item path $baseline folder item type directory right host created baseline storage folder at $baseline folder. Try hashtag collect historical login data $start date equals get date add days. $data collection days. $historical logins equals get twin event filter hashable at log name equals security. ID equals 4624 start time equals $start date. Error action stop. Where object. $_ properties 5. Value. EQ $username right host found $. Historical logins. Count. Login events for analysis. Hashtag analyze login patterns $baseline data equals at username equals $username creation date equals get date last updated equals get date login patterns equals at business hours equals at average equals 0 standard deviation equals 0 after hours equals at average equals 0 standard deviation equals 0 common workstations equals at usual days of week equals at typical source IPs equals at. Hashtag would you like to see what we've collected so far? Junior IT. Yes, I can see it's collecting login data, but I'm not sure what all these patterns mean. How do we know what's normal for a user? Senior IT. Great question. Let's add the pattern analysis component, and I'll explain each part. PowerShell. Copy. Hashtag adding pattern analysis to our baseline $daily patterns equals $historical logins group object $_ time created. Date for each object $day logins equals $_ group hashtag analyze business hours versus after hours $business hour logins equals $day logins where object $hour equals $_ time created. Hour $hour G $business hours start and $hour to $business hours. Hashtag create daily summary at date equals $_ name total logins equals $day logins. Count business hour logins equals $business hour logins. Count after hour logins equals $day logins. Count $business hour logins. Count workstations used equals $day logins. Properties 11. Value select object unique. Day of week equals daytime $_ name day of week right host and analyzing daily patterns. For each, dollar day and dollar daily patterns, right host date, dollar day date, right host business hours logins, dollar day dot business hour logins, right host after hours logins, dollar day dot after hour logins, right host workstations used, dollar day dot workstations used, count. See how we're breaking down the login patterns? For each day, we're looking at when people typically log in, how many workstations they normally use, what their typical work week looks like. Would you like to run this against a test user and see what patterns we discover? Junior IT. Yes, that would help. But what numbers should we consider normal or suspicious? And what if someone has different patterns on different days? Senior IT. Excellent thinking. Let's enhance our baseline with flexible thresholds and day-specific patterns. PowerShell. Copy. Hashtag adding day-specific pattern analysis $day-specific patterns equals $daily patterns group object day of week. For each object, $day data equals $_ group $average business hours equals $day data. The business hour logins measure object average. Average average after hours equals $day data. The after hour logins measure object average. Average hashtag calculates standard deviation for more accurate thresholds $business hours SD equals math : SQRT, $day data, business hour logins for each object, math : POW, $_ average business hours, 2. Measure object average, average. At day of week equals $_. Name average business hour logins equals $average business hours, average after hour logins equals $average after hours, standard deviation equals $business hours, normal range equals at min equals, math : max 0, $average business hours dash, 2 $$ business hours SD. Max equals $average business hours plus, 2 $$ business hours SD. Hashtag let's test with some sample data $test user equals test at user $test data equals get test login data username $test user days 5 right host, analyzing test data against baseline. Would you like to see how this analyzes actual login patterns and determines what's normal for different days of the week? Notice how we're building the concept piece by piece, with each edition addressing your questions and concerns. Should we proceed with testing this against some sample data? Copy. Retry. Oh, yes. Senior IT. Perfect. Let's run some realistic sample data analysis to help you understand how this works in practice. I'll walk you through each step and explain what we're seeing. PowerShell. Copy. Hashtag first, let's generate some realistic test data function new test login data perm. String $username equals test.admin, in $days of data equals 5. Right host, generating test login patterns for $username over $days of data days. $patterns equals at hashtag Monday pattern busy day. A day of week equals Monday normal logins equals at 9, 10, 11, 14, 15, 16. Hashtag regular business hours occasional after hours equals at 17, 18. Hashtag sometimes stays late, hashtag Friday pattern. Leaves early. A day of week equals Friday normal logins equals at 9, 10, 11, 14, 15. Hashtag leaves early occasional after hours equals at hashtag rarely stays late. $test data equals for each $day and 1. $days of data. $date equals get date. Add days. $day. $day pattern equals $patterns where object $_day of week. EQ $date day of week to string. For each $hour and $day pattern normal logins. At time created equals $date. Date.add hours $hour. Username equals $username. Workstation name equals $. Get random minimum 1. Maximum 4. Hashtag simulate 3 regular workstations login type equals 2 hashtag interactive log return $test data. Hashtag let's analyze this data $test user equals test.admin $test data equals new test login data username $test user $baseline results equals analyze login patterns. Login data $test data right host in baseline analysis results. Right host equals 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 right host normal business hours pattern. Right host average logins per day. $, baseline results to average logins per day. Right host typical login times. $. Baselineresults.common login times join. Right host common workstations. $baselineresults.common workstations join. Do you see how the patterns are emerging? Let's now test an unusual login to see how our system detects it. Junior IT. Yes, I see the patterns for different days. But what makes a login unusual? Is it just the time? Or are there other factors? Senior IT. Excellent question. Let's add anomaly detection that considers multiple factors. PowerShell. Copy. Hashtag enhanced anomaly detection function test login anomaly perum. $login event. $baseline data. $anomaly score equals $0 anomaly reasons equals at. Hashtag time-based analysis $login hour equals $login event dot time created. Hour if $login hour node and $baseline data dot common login times. $anomaly score plus equals $2 anomaly reasons plus equals unusual login time. $login hour 00. Hashtag workstation analysis if $login event dot workstation name. Node and $baseline data dot common workstations. $anomaly score plus equals $3 anomaly reasons plus equals unusual workstation. $login event dot workstation name. Hashtag day of week analysis $current day equals $login event dot time created dot day of week $day pattern equals $baseline data dot day patterns $current day dot to string. If not $day pattern, $anomaly score plus equals $2 anomaly reasons plus equals unusual day $current day right host nanalyzing login event right host time $login event dot time created right host workstation $login event dot workstation name. Right host anomaly score. $anomaly score if $anomaly reasons. Right host reasons for concern. $anomaly reasons for each object right host. $_return at. Score equals. $anomaly score reasons equals $anomaly reasons requires alert equals $anomaly score GT. Fourth hashtag. Let's test with some unusual scenarios. $unusual logins equals at time created equals get date. Date at add hours. 23. Hashtag 11 p.m. login username equals $test user workstation name equals WS unknown login type equals 2. At time created equals get date. Date.add hours 14. Hashtag normal time username equals $test user workstation name equals WS. 1. Hashtag normal workstation login type equals 2 right host. And testing unusual login scenarios. For each $login and $unusual logins. $result equals test login anomaly login event, $login baseline data, $baseline results. Look at the different results. The first login triggers multiple anomaly indicators because it's at 11 p.m. unusual time. It's from an unknown workstation. It's outside the user's normal pattern. The second login looks normal because it matches the baseline. Would you like to try adding more scenarios to test? Junior IT. I see how it works, but what if someone has a legitimate reason for an unusual login? Can we add some kind of exception process? Senior IT. That's thinking like a real-world administrator. Let's add exception handling. PowerShell. Copy. Hashtag add exception management $exception config equals at pre-approved Windows equals at start date equals get date. Date at add days 2. End date equals get date. Date at add days 3. Reason equals scheduled system maintenance. Approved users equals at test at admin. Maintenance.service. Approved workstations equals at asterisk. Hashtag any workstation allowed. Temporary exceptions equals at function test login exception perum $login event. Hashtag check pre-approved window for each $window and exception config pre-approved windows. If $login event time created $window start date and $login event time created $window end date and $login event username in $window approved users. Return it is accepted equals $true reason equals $window. Reason return it is accepted equals $false. Would you like to test this exception handling with some maintenance window scenarios? Notice how we're building a comprehensive system that handles real-world situations. Should we continue with testing the exception handling? Copy. Retry. Oh, yes. Senior IT. Great. Let's test the exception handling system with some real-world maintenance scenarios. I'll walk you through this step by step so you can understand how it all fits together. PowerShell. Copy. Hashtag first, let's create a more comprehensive test environment function test maintenance scenarios perm. String $test user equals test.admin. Right host setting up maintenance window testing scenarios. Foreground color cyan hashtag create some scheduled maintenance windows $maintenance windows equals at scheduled equals at start date equals get date. Date.add days 1. Add hours 22. Hashtag tomorrow 10 p.m. end date equals get date. Date.add days 2. Add hours 4. Hashtag day after 4 a.m. description equals monthly. Patch installation approved users equals at test.admin. Patch.service. Emergency equals at start date equals get date. Add minutes minus 30. Hashtag started 30 minutes ago end date equals get date. Add hours 2. Hashtag next 2 hours description equals emergency security update. Approved users equals at test.admin. Security.admin. Right host and configured maintenance windows. Foreground color green for each $window and $maintenance windows. Get enumerator. Right host $window key. Maintenance. Foreground color yellow right host start $window value.start date. Right host and $window value.end date. Right host approved users $window value.approved users join. Hashtag let's test some login scenarios. Test scenarios equals at description equals normal maintenance window login. Time created equals $maintenance windows. Scheduled.start date. Add hours 1. Username equals test.admin. Workstation name equals maint. SRV01. Login type equals 2. At description equals unauthorized maintenance access. Time created equals $maintenance windows. Scheduled.start date. Add hours 1. Username equals regular. A user workstation name equals main. SRV01. Login type equals 2. At description equals emergency maintenance login. Time created equals get date. Username equals security.admin. Workstation name equals SEC. SRV01. Login type equals 2. Right host. In beginning, scenario testing. Foreground color cyan for each $scenario and $test scenarios. Right host and testing scenario. $scenario description. Foreground color yellow $exception check equals test login exception login event. $scenario $anomaly check equals test login anomaly login event. $scenario baseline data. $baseline results. Hashtag evaluate combined results. $final evaluation equals at is allowed equals $exception check that is accepted or $anomaly check. Score. Look for reason equals if $exception check that is accepted. Approved maintenance window $exception check reason else if $anomaly check. Score GT4. Suspicious login $anomaly check reasons join else normal login pattern right host result. Foreground color cyan right host access allowed $final evaluation is allowed. Right host reason $final evaluation reason. Hashtag log the evaluation right monitor log message. Login evaluation for $scenario that username final evaluation reason. Level if final evaluation is allowed. Information else warning. Hashtag run our test scenarios. Test maintenance scenarios. Do you see how the system handles different types of maintenance access? Notice how it checks if the login is during an approved maintenance window. Verifies if the user is authorized for maintenance. Still applies anomaly detection for unexpected patterns. Would you like me to explain any particular part in more detail? Junior IT. Yes, I see how it's checking the maintenance windows, but what happens if there's an emergency and we need to add a maintenance window quickly? Should we add some kind of emergency override process? Senior IT. Excellent operational thinking. Let's add emergency override capabilities with proper logging and approval tracking. PowerShell. Copy. Hashtag emergency override management function and emergency maintenance window parameter mandatory equals $true. String $requested by parameter mandatory equals $true. String $approved users parameter mandatory equals $true. String $reason in $duration hours equals 4. String $approver name right host. Processing emergency maintenance request. Foreground color red right host requested by Dollar requested by right host duration. Dollar duration hours right host reason. Dollar reason. Hashtag requires second level approval for emergency. Windows SIF. Not dollar approver name. Right host error. Emergency maintenance requires approval. Foreground color red return dollar false. Dollar emergency equals at start time equals get date end time equals get date dot add hours dollar duration hours. Requested by equals dollar requested by approved by equals dollar approver name reason equals dollar reason approved users equals dollar approved users created equals get date. Hashtag log the emergency window creation right monitor log message emergency maintenance window created. Dollar reason level warning. Right monitor log. Message approved by dollar approver name. Level information dollar exception config temporary exceptions plus equals dollar emergency right host. Emergency maintenance window created successfully. Foreground color green right host valid until dollar emergency dot end time. Return dollar true hashtag let's test an emergency scenario right host. End testing emergency override process. Foreground color cyan dollar emergency result equals add emergency maintenance window. Requested by helpdesk.manager. Approved users at emergency.admin, backup.operator. Reason critical database restore operation. Duration hours 2. Approver name, it at director if dollar emergency result. Hashtag test an emergency login dollar emergency login equals at time created equals get date username equals emergency.admin workstation name equals db SRD01 login type equals 2. Dollar result equals test login exception login event, dollar emergency and right host, and emergency login test result. Foreground color yellow right host access allowed. Dollar result that is accepted. Right host reason, dollar result, reason. This enhancement provides emergency override with proper approval tracking. Time-limited emergency access. Detailed logging of who authorized the emergency access. Automatic expiration of emergency windows. Would you like to test some additional emergency scenarios or explore how we might add automated notifications for emergency access? Notice how we're building in both security controls and operational flexibility. Should we continue with notification system implementation?
So as you can see here, very long answer, very detailed one, very real one, with more enhancement, answer after answer. So I think after that we need to have a little bit of summarization for all of the scripts that was introduced, and a general idea about the what the whole script will do so far. So first, let me show you something here. So here at the end I asked him to give me the final script. Okay, here this is the complete script, and actually I was suspicious about the scripting language, so I asked ChatGPT o1 to analyze the script, and not only analyzing it but also to give me an idea about what the script do exactly. So let me show you here something. So for example here I tell him I need the whole conversation summarized between the junior and the senior IT. So let me read the summarization of all of the things. So here is the whole script, and we will try to correct it with ChatGPT o1 if there is any enhancement or any incorrect coding. And here is a summary of the conversation between the junior and the senior IT. Let's see the answer.
Here's a structured summary of the conversation between the junior and senior IT regarding Windows Event Log Monitoring. Initial understanding. Copy. Junior IT. Event logs are like records of things that happen on Windows servers. Senior IT. Use banking analogy. Vault access equals authentication events. Access timing equals timestamps. Activities inside equals user actions. Break-in attempts equals failed logins. Basic concepts clarification. Copy. Junior IT learned. Event ID 4624 equals successful logons. Event ID 4625 equals failed logons. Different logon types. Asterisk type 2 equals interactive/local asterisk type. 3 equals network asterisk type. 10 equals remote desktop. Monitoring setup discussion. Copy. Senior IT introduced. Business hours monitoring, 9 a.m. to 6 p.m. After hours alerts, multiple failed attempts tracking, admin account usage monitoring. Implementation concerns. Copy. Junior IT worried about. Too many alerts, false positives, normal versus suspicious activities. Senior IT addressed with. Baseline documentation, pattern recognition, exception handling. Script development. Copy. Together they built. Business hours checking, anomaly detection, maintenance windows, alert thresholds. Testing and refinement. Copy. Develop test scenarios. Normal business hours login. After hours unauthorized access. Scheduled maintenance access. Emergency maintenance. Advanced features discussion. Copy. Added functionality for pattern analysis, baseline deviation detection, emergency override process, logging and reporting. Production implementation. Copy. Final implementation included scheduled task setup, log rotation, error handling, health monitoring. Key learning points. Event log basics. Understanding event types. Identifying important event IDs. Reading and interpreting logs. Security monitoring. Authentication tracking. Anomaly detection. Baseline establishment. Operational considerations. Maintenance windows. False positive management. Alert thresholds. Best practices. Regular baseline updates. Exception handling. Documentation importance. Implementation steps. Script development. Testing procedures. Production deployment. Progression of understanding. Started with basic concept understanding. Moved to practical implementation. Added complexity gradually. Addressed real-world scenarios. Finished with production-ready solution. Would you like me to expand on any particular aspect of this interaction or provide more details about specific components discussed?
So here is the summary, and when I ask ChatGPT o1 to I give him the whole script, and I ask him to explain what does this script do exactly. And actually also I told him to review the script and see if there is any enhancement or any error in the coding. Let's see the answer here of what is the main function of, we name this script AD event monitor script. Let's see the answer and what is exactly this script do after all of these enhancement and all of these discussions.
This script is an Active Directory AD event monitoring solution designed to track, analyze, and respond to potentially suspicious or critical security events in an organization's AD environment. Here's a summary of its functionality. Key features. 1. Setup and configuration. Initializes directories for logs, baselines, and configuration. Configures business hours and monitoring parameters like start and end of business hours. Monitoring intervals, default every 5 minutes. Log retention duration, default 30 days. Admin group SID for monitoring privileged accounts. 2. Logging and transcripts, logs all script activities and events to daily log files. Records actions in the Windows event log for auditing. 3. Event monitoring. Monitors specific AD-related security events, e.g. logons, group modifications, by fetching logs from the Windows security event log. 4. Anomaly detection. Checks logon activities for anomalies like logins outside business hours, unusual frequency of logons, logins from multiple unique source computers. Generates an anomaly score based on the severity of suspicious behavior and flags activities requiring alerts. 5. Alerting. If suspicious activity is detected, e.g. an anomaly score exceeding a threshold, it generates an alert log and provides details about the event. 6. Log maintenance. Automatically archives old log files beyond the configured retention period. 7. Task health monitoring. Ensures the scheduled task running the script is active and healthy. Restarts it if it's not running or reports failures. 8. Continuous monitoring. Runs in a continuous loop to monitor events at regular intervals, with a sleep mechanism between iterations. Use case. This script is ideal for organizations that want to enhance their AD security posture by identifying and responding to potential threats, like unauthorized logins or after-hours activities, privileged account misuse, suspicious group or account changes in AD. Let me know if you need further customization or additional insights.
So forgot to say that he has added a couple of lines to the end of the script uh, so he considered that you have will run this script through a scheduled task. So he added a couple of lines to this script to check if the scheduled task is running or not. So this is something also to make sure that the script is running regularly. If we go to the script, here you go, I asked him to analyze the script and see if there is any changes. So at the end he give me, this is the whole script. Let me show you all the script in general. So let's have the script in general. So here is the script. For example, here he's talking about you need to run a scheduled task. So this should be run as a scheduled task. We need to make the monitoring interval to be 5 minutes. You need to integrate with email services. So example, to send an email, this script to send an email enhances security, not the script with least privilege. Log enhancement, implement different logs, debug informational warning error handling. Anyway, optimize performance optimization requires to reduce load efficiency requirements, so on. So add documentation. So anyway, here is the script. At the end we have this script, so we can, here is the whole script from the beginning, if you can see, or just check it, a long script. We see a lot of things here. So we can see here AD monitoring solution. We can see these are the paths for the logs, and then we have business hour configuration, the monitoring table 5 minutes, log retention 30 days, group filtering. So the retention, I think, for the logs in the folders, okay, he will not these are manual logs, not in the event log. These are manual text logs, okay. And you can see here also he is getting the admin group SID. So in the original script he already have the SID, but here he is getting them by the name, okay. Then we can go further, initialize directories. If these directories are not done, he will create them. Then start transcript logging to log all what's happening by the script. Then he will record this, so we'll have a log for the script and what he's doing in a text file, and I think he will also, the whole process will be written to the event viewer under informational kind of event with the stamp and so and so. So we have two ways for monitoring text files and the event log, or in the event viewer, write to monitoring log, okay, so write to Windows events. So we have two things here, and then we can continue the business hours, okay, we have already defined it. Then we will get to the login patterns, okay, and analyzing the login pattern for every user, and test anomaly, adding anomaly, or if there is any anomalies or unusual activity after analyzing the pattern for each user. We have a pattern file for each user. Then after that we will know if this is correct or not. Function start log rotation. So this is how we can rotate the logs, the text logs, okay. And then this is the last thing that was added, but I did not mention it, test monitoring task health. So you will create a scheduled task that will run all of this script, okay. And here he having a part in the text or a part in the script to check this schedule task, okay, that run this script. So okay, we can see here, okay, start function, so and so. So star event monitoring, he will see all of these events, and you will got any anomaly detected. Okay, and at the end you can send an email, but here we don't have this implemented in the script. Okay, main execution. So anyway, this is the whole script. You can add it and try to see if it will work or not, but actually I have already uh, discussed this script with a lot of AI tools, and this seems to be correct, but we need to implement it in a test environment or in a production environment if this or I prefer in a virtual environment first. But here is how we can use AI tools, and actually this lesson is very useful, and actually in the upcoming video we will begin discussing another kind of events. I have already uh, uh, get a hint about that. We will discuss this in the previous in the upcoming video. We will discuss another thing here. If you see this, we have uh, Microsoft has already a couple of events. If we see them, let me show you something here. So this is events to monitor. So these are monitoring Active Directory for signs of compromise. There is a whole lot of events that indicates a compromisation for the Active Directory. I have already tell ChatGPT-o1 all of these events, and I ask him to create hands-on exercise for these events and security case for this event, and the same for Claude. So until stay tuned for the upcoming video, we will see how also AI tools will give us scenarios concerning these events, which seems to be larger than the PDF that I have already used for many years now, and also for Mr. Lobandel for event IDs. These are a lot, so let's see how we can have scenarios concerning all of these events. Hope this video informative you all, and thank you all for viewing. Thank you so much.